Find the binomial expansion of cos theta plus I sin theta to the power of 5. Give your answer in the form a plus bi, where a and b are expressed in terms of sin theta and cos theta. By using the Moivre's theorem and your answer to part A, show that sin 5 theta is equivalent to 16 sin power 5 theta minus 20 sin cubed theta plus 5 sin theta. Hence show that theta equals to pi over 5 and theta equals to 3 pi over 5 are solutions of the equation 16 sin power 4 theta minus 20 sin squared theta plus 5 equals to 0. Hence show that sin pi over 5 sin 3 pi over 5 is equal to root of 5 power 4. Okay, so for our first question here, which, hold on, my pen is not working. We just have to remember our binomial expansion here, in which we already have the formula here in your formula booklet, and you just need to identify which is A, which is B, and which is N. So here, let's put this here, cos theta plus I sin theta to the power of 5, okay? So we do this is cos theta power n, which is 5, plus 5c1 and cos theta power 4 times I sin theta plus, and then we just decrease, okay, so plus 5c2, and then decrease the power here by 1, which is cos theta power 3, and then increase the power here by 1, so we have I sin theta squared. Then we do this even more until we reach the third here, the fifth. So cos theta squared I sin theta power 3 plus 5c4 cos theta power, okay, so it's power 1, so I sin theta power 4 plus 5c5 cos theta power 0 times I sin theta power 5. Alright, so from here we have our equation. Let's simplify it even more and also figure out our 5c1, 5c2, 5c3, 5c4, and 5c5. Okay, so here we can expand this. So we have cos power 5 theta plus 5c1 is 5, and then cos power 4 theta and I sin theta. All right, then we have 5c2. Let's work out 5c2. Our 5c2 here would be 5 factorial over 2 factorial 5 minus 2 factorial. And here we just need to put this 5 times 4 times 3 times 2 times 1 over 2 times 3 times 2 times 1, and we just cancel this out here, and we would be left with 5 times 4 over 2, 20 over 2, which is 10. Then that is our 5c2, so we have 10, and cos cubed theta I squared sin squared theta plus 5c3. We can do this again. Okay, and here we would have 5 factorial over 2 factorial 5 minus 3 factorial, 5 minus 3 factorial. Then we would have 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 and multiplied by 2, in which we cancel this out here, and we would be left with 20 over 2 again, and this is 10. Okay, so we have 10 cos squared theta and I cube sin³ theta. And notice, okay, so a little bit of a tip here, right? So when we're looking at a binomial expansion, and then the values here are the same. So this is when the mirror starts. So that means that the next one will be 5, and the next one would have no integer in front. All right, so we have 5 cos theta, I power 4 sine power 4 theta plus sine I power 5 sine power 5 theta. If you don't believe me about the mirror, okay, so 5 here is 5c4, all right? Let's try to do 5c4. If we try to do 5c4 here, 5 factorial over 4 factorial, 5 minus 4 factorial, and we would have 5 times 4 times 3 times 2 times 1 over here 4 times 3 times 2 times 1 times 1 actually because of this. We just cross this out, and guess what? We're left with 5. So just so you know, in all binomials, they have a sort of mirror. So 10, 10, 5, 5, 1, 1, right? Okay. So next we have to understand what are imaginary numbers. Okay. So imaginary numbers. What is an imaginary number? An imaginary number is the root of -1. So if we go even further with this, I squared would be -1. Then our I cube would be minus root of -1, which is minus I. Then our I power 4 would be minus I times root of -1. So minus root -1 times root -1, which would be -1. All right. Wait, it would actually be I squared squared, which is the same as -1 times -1, which would then just be 1. Okay. And I power 5 would be 1 times root -1, which is just I. That's just root -1. Okay, so let's come back up here. We just have to put this out. Cos power 5 theta plus 5 cos power 4 theta I sine theta. We don't need to change the I there. Then 10 cos power 3 theta. I squared, what is I squared? I squared is, whoops, sorry. I squared is -1. So let's just change this here. Minus, and then yeah, 10, okay, minus 10 cos cube theta, sine squared theta, plus, and then our I cube would be, whoops, sorry. Our I cube here would be minus I. So we would have minus 10 cos squared theta I sine cube theta plus, okay, our I power 4 here. Oops. I did not mean to do that. Our I power 4 here would be 1. So it would be plus I 5 cos, wait, my pen's not working, plus 5 cos theta sine power 4 theta, and plus I sine power 5 theta. Okay? Now we have to put that in the form that they want us to, which is a plus bi, in which a and b are expressed in terms of sine theta and cos theta. All right, so that means that we need to factor out I. All right, so here, let's separate the ones that do not have I first. So here we have cos power 5 theta minus 10 cos cube theta sine squared theta plus 5 cos theta sine power 4 theta here, and plus, okay, now we start factoring out I out of here, like here and here and here. So we do this one first, which is 5 cos power 4 theta sine theta minus 10 cos squared theta sine cube theta plus sine power 5 theta. And this is your answer for the first question. All right, and on to the next question. By using the Moivre's theorem in your answer to part A, show that sine 5 theta is equivalent to 16 sine power 5 theta minus 20 sine cube theta plus 5 sine theta. Okay, so for part B, we have the Moivre's theorem right over here, which is r cos theta plus I sine theta power n is equal to r power n cos n theta plus I sine theta, n theta, I mean. All right, so by knowing this, we just need to take our equation here, which is cos theta plus I sine theta to the power of 5, and we would be able to turn it into this equation right here. So we would have cos 5 theta plus I sine 5 theta. Now, since we already got our equation in the one above right here, by rearranging it into this equation right here, we now know that sine theta right here, sine 5 theta, I mean, would equal to this right here. All right. So it would be 5, hold on, okay, 5 cos power 4 theta sine theta minus 10 cos squared theta sine cube theta plus sine power 5 theta. Right, and we're trying to get it in this form right here, which eliminates all these cosines over here, since we're only trying to get it in sine power 5 theta, sine 3 theta, and sine theta. All right, so we can do this by looking at our double angle identities. And one of the formulae here is the cos squared theta is equal to 1 minus sine squared theta. From here, we can actually find an equation for cos power 4 theta. And here, we can see that cos power 4 theta can actually be developed by just squaring cos squared theta, because this times this equals to 4 by the law of exponents, right? And from here, I don't know why my pen isn't working. From here, we can just do 1 minus sine squared theta squared. From here, we can do 1 minus sine, just do this to make it easier to see, and then start multiplying. So minus 2 sine squared theta plus sine power 4 theta here. All right, and from there, we can start to just substitute our values of cos power 4 theta and cos squared theta into this equation right here. All right, so we would have sine, let's move it to here. All right, so sine 5 theta is equal to 5 of 1 minus 2 sine squared theta plus sine power 4 theta sine theta plus 10 and then 1 minus sine squared theta sine cube theta plus sine power 5 theta. And from here we can just start multiplying the brackets here. So we would have 5 minus 10 sine squared theta plus 5 sine power 4 theta sine theta plus 10 minus 10 sine squared theta sine cube theta plus sine power 5 theta, and then just do the rest of the multiplying, the rest of the multiplication here. So we would have 5 sine theta minus 10 sine cube theta plus 5 sine power 5 theta plus 10 sine cube theta minus 10 sine power 5 theta plus sine power 5 theta. And from here, we can just do our calculations. 5 sine theta, there aren't any sine thetas, any other sine thetas with no exponents. So we just have this 5 sine theta, and then our sine cube theta, minus 10 plus 10. Wait, this isn't right. Yeah. Okay, so we forgot here. My bad. So this is supposed to be minus. So that means that this would be plus. Okay. Minus 10. Okay, so we would have minus 20. My bad. Sine cube theta. Then we would have 5 sine theta plus 10 plus 5. Okay. Then it would be 16 sine power 5 theta. Then we just rearrange it a little bit because keep in mind we are trying to get this value right here, all right? If your equation doesn't match that, then you need to check your calculations. And we just have this 16 sine power 5 theta minus 20 sine power 3 theta plus 5 sine theta. And this is the answer for part B, right? We're trying to get this. Sorry. And for CI, we need to show that theta equals pi over 5 and theta equals 3 pi over 5 as solutions of 16 sine power 4 theta minus 20 sine squared theta plus 5 is equal to 0. Okay, so from here, we can actually get this from our previous equation here. So 16 sine 5 theta is minus 20 sine cube theta plus 5 sine theta is equal to Okay, we can factorize sin theta out here. So sin theta times 16 sin power 4 theta minus 20 sin squared theta plus 5. Okay, and we can see that from here, this is equal to 0, right? So our sin 5 theta here, which is this entire thing, can equal to 0. And from here, we can check for solutions to find a theta that works, right? So from here, we can check their solutions here. So sin pi over 5, sin 5 pi over 5, in which this and this cancel out, so sin pi is equal to 0. So this is correct. And after that, we can check for our next one, which is 3 pi over 5. Cancel this out, and then, wait, I did not see that I put c there. Done. Sine, okay. And then so we cancel those out, we have sin 3 pi. And sin 3 pi is also equal to 0. All right, so from here, this is also correct. And after that, we can show that sin pi over 5, sin 3 pi over 5 is equal to root 5 over 4. From this, we can actually use our previous equation here, 16 sin power 4 theta minus 20 sin squared theta. Oops. I don't know why my thing stopped working. My pen just stopped working. Plus 5 is equal to 0. Now we can consider sin squared to be x. So sin power 4 here, let's turn this into 16x squared minus 20x plus 5 is equal to 0. Now this looks like a quadratic equation, but what we're trying to see here is that sin pi over 5 and sin 3 pi over 5 are a product of two roots, right? And a product of two roots here, all right, so let's just put this here. Sin pi over 5 and sin 3 pi over 5 here, okay? This one would be alpha, this one would be beta. Alpha times beta is equal to c over a. So this is our c, and this is our a, because this is in the form of ax squared plus bx plus c. Okay, so sin squared theta over 5, sin squared 3 pi over 5 is equal to 5 over 16. So trying to get rid of these squares here, it would be sin pi over 5 times sin 3 pi over 5 is equal to root of 5 over 16, which is also root 5. I don't know why it stopped working. My pen stopped working. Hello, my pen. Is that pen gonna start working? Okay, there you go. Which is also root of 5, 16 over 4, because a root of 16 is 4, root of 5 is root of 5. So that's how we get sin pi over 5 times sin 3 pi over 5 here. And as we go up, that is the question. Remember that whenever it says show, that means you're trying to get this equation here.